Hello, Mr. Kada, how are you?
I'm good, Professor Oji. How are you?
Good, thank you. Let's wait for a few minutes. See, oh, somebody's joining us now. Okay, good. So we can begin. Yeah, she's Kayana is joining us. Have you finished the homework that I opened? Mr. Kada, you there?
Yes, I am here. I did not finish it. I actually was gonna email you about that. It all closed.
Email me the one that's want me to open because we don't have much time left.
Okay, got you.
How about the project?
Yeah, I finished that. I submitted it.
Oh, very good, very good. Kayana, how are you?
I'm okay. How are you?
Good, good. So let's begin. This will be our last lecture for the semester. So next week, you don't have to come to class. I will post the date for the final exam, and the final exam will be taken in Canvas. Before I show you, let me just show you where to find it. Let me pull up the class, the course announcement page so that you can see what the things that I do this week. We have it here. Only this. Want to close some of these things there. They are open, so we can have room for. Yeah. Close this. Yeah. So next one I want to close is this one, so we can have enough room here. Okay. I think I might close this page. This page is no. Let me leave this page. Or maybe I can close it. All right. Anyway, you can see this your home the announcement page for your class in the Canvas. You can see it, right? Can you?
Yes.
Yes, I can see it.
So you can see what I do this week. I have 2 assignments. I put project. I didn't put any dates. But I know that I put a date, the due date on the assignment section when it is due. So you go by that due date. And homework 10, it will be available by tomorrow. So it will be due on the 15th. So after this, and after your project, the next thing you have is the final exam. Final exam, I will create, when I create it, it's not going to be, well, it will be the same place. I make it to be the same place that you take your tests, which is in the My Lab and Master here. So the same place you do your homework and test, that's where I'm going to put the final exam so that you can go there and take it. So when I make an announcement, I put it, you can take it earlier before the due date. So for what we'll be doing tonight is from chapter 14 of the course textbook. Let's begin. I have this. The basic concepts we have. Correlation and regression are the thing we are doing tonight. We'll do only the simple correlation and regression. We're going to do the multiple correlation. So, well, in correlation, what we do is to measure the extent that to which 2 variables, 2 or more variables, move together or fluctuate together. So, for regression, our interest is in determining the strength of the relationship between one independent variable and a series of other independent variables or changing variables. So the strength of the relationship between one dependent variable and a series of other independent variables. So the dependent variable will use y to present it. And for the independent variables, we use x to present it. Now, the question to ask at this point is, what kind of questions can we answer using correlation and regression? Well, a business owner may want to know whether the sales that the company is getting is related to the amount of advertisements that the firm did that month. So does advertisement pushes sales up or not? Teachers may be interested in finding out if the number of hours a student studied is linked to the score that the student will have in a test or exam. Medical researchers may be interested in questions like, does age affect blood pressure? Can COVID-19 vaccine really protect us from the disease? So there are so many questions that involve dependent variable and independent variable that we can answer using correlation and regression. Now, at this point, it is necessary to explain the meaning of dependent variable and the independent variable. The dependent variable, which is also called the Y variable, refers to the variable that we cannot control. For example, things like sales, total sales. Yes, we cannot control it. We can influence it by advertising more or by making quality products, but we cannot control how much increase the sales will be. Another thing is good health. And a good example. Yeah, you might set to influence do things that will make your health, that will improve your health, but you cannot decide or determine how much improvement, exactly how much improvement that will come from doing more exercise or eating the right kind of food. But you can say, okay, I want to be healthy, so I eat this. But you can't say I'm going to be 100% cholesterol free. No, you don't have control over that. You can only influence it. And I think it's great. You can study hard and push your grade up, but how far are you going to make it A? It's not always easy to determine that, control that, because there are many other factors that can come in. You might study so hard, study up to late in the night. Then you didn't woke up on time, so you came late for the exam and then didn't finish on time. Or you might study so much and come to the exam and pass the exam with an A. Or you can study so hard, but when you came to the exam, they asked more questions from the area that you are finding difficult. So, because you cannot control them, we call them dependent variable or the Y variable. The S variable or the independent variables, these are the ones that we can control. For example, I can say, I will exercise, I will do 20 push-ups today. Yeah, I can control that. Or I can say, okay, I'm going to spend $3,000 in advertisement. Yeah, I can control that. So we call them the independent variable or X variable. Some people call it the predictor variable. Now, dependent variables, sometimes they call it the response variable. Now, in correlation, we are trying to estimate the rho, which is the correlation coefficient. For this level, what we are looking at for is the Pearson product moment correlation coefficient. That's the one we're trying to determine. So we use the R as an estimate of this rho, the correlation coefficient. So we R as estimates, where R represents sample correlation coefficients. So that will tell us the degree of association or relationship between the dependent variable and the independent variable, depending on the value. So the value ranges from -1 to +1. You can see from this chart. If your answer is -0.5, that means that let's say that this is -0.5, which is at the center you see 0. That means no correlation. This is negative correlation. This is on the side right side is positive correlation. So if your answer is 0.05, for example. This indicates weak. I'll say indicates. I'll make it bigger. Okay, I'll make it black. So indicates a weak negative linear relationship between X, which is independent variable, and Y variable. But if your answer is something like negative 0.6, for example, this is 7, for example, 0.70. See, indicate a strong, because it is closer to -1. I'll have the strong negative relationship between X and Y. On the same thing with on this side, as it gets closer to +1, for a value like let's say 0.85, 0.85, for example. I mean, it's getting closer to the +1, indicate a strong negative, positive. This time is positive linear relationship between X and Y. That means as S increases, Y also increases. But when they get close to 0, they become weak. When they get close to +1, they become strong. Same thing with the left side. If they get closer to -1, they become stronger. For negative relationship, when one variable increases, the other variable decrease. For example, speed and time. The higher the speed, the less the arrival time. Assuming that you didn't crash the car or you're not stopped by a speed cops. Yeah.
Mr. Oji.
Yes, sir.
Is this document in the file section of Canvas?
Yeah. Let me show you. Give me 1 minute. Let me show you from here from the classroom. You go to files. If it's not there, then I'll put it. I think it's there. Right here. Can you see it?
Yes.
Can you see it?
I see it.
It's right there.
Hypothesis testing.
You see, you can see my hand, right?
Yeah, I can see it.
Okay, that's so you can download it from there.
All right.
So now, going back to where we are, we can also represent this graphically. But look at how we categorize the values of R. If R is between 0 and 0.2, like here, let's say 0 and 0.2, we might be around here. That's 20%. That means very low relationship. According to this, the strength of relationship. If it's 0.4, 0.2 to 0.4 is low. And if 0.4 to 0.6, moderate relationship. From 0.6 up, highly moderate, but from 0.8, it becomes very high. So like we can also present the relationship using diagram. And we call that diagram the scatter diagram or scatter plot. So we use the scatter plot as a visual way of describing the natural relationship between the dependent variable and the independent variable. Like here, if you look at this one indicates, I wrote it down here, indicates a strong positive linear relationship between X and Y. Because it's, see, S is going, it is trending up. As S increases, Y increases. This one here, scatter plot, indicate a strong, this one is positive. relationship. This one is a strong negative relationship between S and Y. It is trending down. As S increases, you can see that Y decreases. So if S is 200, Y is up, way up, -2. But when S is 400, Y decreases to -0.3, 3.6. So this one example of this one is hours of study. When you study hard, you spend more time studying, your grade goes up. This one is going to be speed and time. The higher the speed, the lower the arrival time. It would be a good example for this. 1 minute. Okay. You can have it. Yeah. So now this one does not show any relationship at all. There's no relationship at all. It doesn't show any pattern. For example, number of hours of study and the number of arrests made in Baltimore City. They don't correlate. Yeah. So sometimes things that are not related might correlate. That doesn't mean that they are related. Any questions so far? Any question?
No, not from me.
Okay, good. Now, the correlation coefficients, like I said, we use R to estimate it. There's another one we call the R squared. We call it the coefficient of determination. It explains to us how much of the variability of a factor can be caused or explained by its relationship with another factor. We'll come to that when we start interpreting results of the correlation coefficients, of the result of the correlation coefficient. Now, another thing we try to estimate in the correlation coefficient correlation is the regression coefficient. So, regression equation is made up of Y, which is the dependent variable, equals B0 plus B1x, where B0 is the y-intercept and B1 is slope. Slope is one we are more interested in, but it tells us the rate of change. Now, to calculate, to estimate all these things, the R, which is here, and then R squared and other variables. We need all these formulas here, the computational formulas. You can see, just to estimate the R, we have to go through all these formulas. Then, after that, we can see, after going to 10, you can now use this for R. There's another formula you can use as well. All this takes you time. Then to get your B1 and B0 might take you an hour. But the good news is that we are going to use the Excel, make it more easy for us. You can get them in 5 minutes, even 3. You get everything together and answer. The alternative formula you can use for R is this one. Then that means you need to calculate this part, calculate this and that, calculate this, and then put it. So, and that will give you only the R. It won't give you the B0, B1, and so on and so forth. So again, that's why we prefer the Excel method. Now, let's do an example. This question says, let me add so that we can do a lot of things here. Let me see what I can add. Calculate the correlation coefficient. Input B. I'm going to clean all this so we can have enough room. Okay. Add a lot of things there. So we can know exactly what we are looking for. I close all this. Okay. Delete all this. Okay, now this is the question we have. The question says, I'm gonna clean all this. Let me clean all this so we can have room. Okay. or we can use the other equation here. Okay, I use this. This might be better. Let us use this one. All the questions I have things on it. Let me use this one. That'll be better. Yeah. I still have this. It says construct a scatter plot. All right, have this. I'll remove all this. Okay. Just let me take these things out. Good. Now we're ready. Look at it. We should the table below shows the mileage and prices in thousands of 8 cars in the car mart. The mileage, this mileage is in thousands. For example, this 21.8 means $21,800. The price. 16 means $16,000. He said, for this one, construct a scatter plot for this data. Then calculate the correlation coefficient R, compute the value of R squared, and explain your results. Then it says, what is the predicted price for a car with 5,000 miles? And then it says here, is there a relationship between mileage and car price? So, is there a relationship between mileage and car price? That means you have to test hypothesis. Okay. F. All right, let's do it. First thing is to put this in Excel. Let me make sure you're seeing this. Yeah, you're seeing it. First is to put all this in Excel. So I'm gonna put everything in Excel. So we can now get this out. We go to Excel and put them in. My Excel is somewhere. What is it? Right here. I put numbers 8. This is the mileage right here. In thousands. The price. See? Mileage and price. So now we have everything that we need. Then we can go and construct our get and do analysis and get the result. So what you're going to do is click on data. Data analysis is not here on my own. So if not there, all you got to do is to put it in. So to put this, I'm going to go to home, file, options, add-ins, then analysis 2-pack. Can go, click on go. So I'm going to, there are 2 of them. I'll pick these 2 and click OK. So that when I go back again and click this, it will show me the analysis 2-pack. So now let's start again. Data. You can see that the data analysis is here now. You can see right there. So I click on that to bring this up. We are doing the regression. Click on regression and OK. So for the mileage, which is the mileage is the dependent variable, price dependent variable. So I start with price. See the Y input Y range. So Y is the price. So I'm going to put it, click on this and then put it in. Okay. The out and input range for the X variable, which is X variable is the mileage. So I choose this, including the name title is mileage. I put it right here. Then because I also included their names. So I'm going to check label, add confidence interval. If I want, if you don't want it, you check it off. So output options where you want it to be. So I want it to be under here. And then that's what I did. Now it said to draw, the question said draw scatter diagram. So I'm going to put, let's say I put residual and then put this line of fit plot. That's what you're going to use for scatter diagrams. And then click OK. You can see everything is here. You can see the scatter plots. Now we can do this. We can now answer all the questions that we are asked to answer. First one, the first question they asked us to answer is this one here. It says, construct a scatter plot for that. And here is the scatter plot right there. The scatter plot is right here. See? So you can just click on it and copy it. Copy. Then go and paste it in your workbook. That's your scatter plot right there. Click here and paste it. So if we look at the scatter plot, you will discover that it is trending down. It's mileage price. So the higher the mileage, see, mileage of let's say it's almost 80,000 miles. It's a price of $10,000. For mileage of about 15,000 miles, mileage might be the higher the price. So it's about 8,000 miles. It be about $18,000. So it's trending down. So it shows a negative linear relationship between the dependent variable and the independent variable. So interpretation of this. This shows, this indicates a negative linear relationship between X and Y, where X is the mileage and Y is the price. So this means that as the price increases, as mileage increases, price decreases, and as the mileage decrease, price increases. Any question on this? Any question on this? Any questions? Okay, good, excellent. Now, as this says, calculate the correlation coefficients R, that is the correlation coefficients. So it's already calculated for us. Because this is trending down, it's a negative relationship. So our answer will be a negative answer. So R equals let's see what it is from our Excel. You can see the R right here. Make it a little bit bigger. You can see right here. See? And I can make it expand this. So you can see the screen better. Okay, good. So it's basically 0.76, 2.76. So 0.76 would be our R. 0.76. Okay. And that means it is strong. Look at here. Our criteria 0.76. You will see that it is say 0.6 to 0.8 is high. So it's moderately strong, I would say. 0.76. So it indicates a strong negative, because you can see that the trend line is going down. So it's going to be negative 0.76 because this is trending down. So this indicates a strong interpretation Okay. This indicates a strong negative negative linear relationship between X and Y, which means that as S increases, Y also increases. If S increases at a higher rate, Y also increases at a higher rate. You know. And what it means, we have a less time, so I'm going to time us out because the time we have left may not be enough for us to complete this. So let me time us out. When I time us out, wait for 10 minutes and log back in so that we can finish up. Okay? Hello, can you hear me?
Yes.
You said wait, how many minutes?
10 minutes, then log back in. Okay?
You wait 10 minutes before logging back in?
Yeah.
Yeah, I see the timer at the top. It shows up.
Yeah, it will not be enough for us to finish this.
Gotcha.
So, yeah. All right. So I see you in 10 minutes time.
All right.
Yeah? All right.
Yeah.
Okay.